multi-layer perceptrons or MLPs. So let us quickly recap. We had this cell body here. We had inputs going in. We performed first the summation, which was followed by an activation function, and we got some outputs here. So this was the structure of a perceptron. Now many perceptrons together form a layer, and many of such layers formed a multi-layer perceptron. Okay, so now let me dive more into this multi-layer perceptron. So this, as you can see, is a multi-layer perceptron. We have 3 inputs. This is the input layer because all the inputs are going in here. This is the hidden layer and this is the output layer. So input layer has 4 nodes, hidden layer has 2 nodes and output layer has 1 node. So how does all of this start? We know the structure, we know the inputs, we know we'll get this output. What exactly happens in between? So first the inputs will be multiplied with the weights, if you remember. So let us take the first input node of the input layer. So all these inputs are going into this first node of the input layer and they are getting multiplied with weights. Now there is a particular way to write the weights. So here, since this is the first input, we have W1 and this is going into the first node. So W1, 1. And since this is the first layer, so a superscript of 1. Again, W, this is the second layer input going into the first node, W2, 1 and the first layer, so superscript 1. Again, W, third input, 3, first node, 1, first layer, 1. Right? I hope you're getting an idea of this. This can be kind of daunting in the beginning. So then this happens and this goes on and on till we reach the last node of the input layer. So here what will be the inputs? X1, X2 and X3 and the weights W. First input going into the fourth node 1, 4, first layer. Second input going into the fourth, first layer again. And third input going into the fourth node is followed, this is of the first layer, right? So this is what exactly happens. And since there are a lot of weights, it becomes kind of very messy. Hence, to keep everything in order, we feed it into the computer in the model in the form of a matrix of 3 cross 4 dimensions. Here 3 stands for the number of inputs and 4 stands to the number of nodes in the layer. Okay, so we know that this is going in. We know that this is going in. 1, in and in. We know that the weights are going to be W11 first layer, W21 first layer and W31 first layer, right? And we know this is a perceptron. So it has 2 parts. First the summation part and second the activation function. And you have the outputs here. So let us write this in the form of a function. So the first thing, let us represent this as Z. Z is actually the summation of the multiplication of the weights with the inputs. Z superscript 1 because of the first layer and the first node, so subscript 1 is W11 superscript 1 into X1 plus W21 superscript 1 into X2 plus W31 again superscript 1 into X3. So this is the summation. We also add another term called bias and you get all the summation here. Now bias is not compulsory, it is an optional part, you can or cannot add it. So the first part is over, we got the summation part, the next part is the function part. So this Z11 will pass through a function and will give an output H. Let us consider that output to be H. So H for the first layer, so superscript 1, and the first node 1 1. So this is how it happens for the first one. So the same thing will happen for the second one again. Second one Z superscript 1, second node. Let me just clear this first. So we have x1 going in. What will be the weight? W1 2 superscript 1. x2 going in. W2 2 superscript 1 and x3 going in. W3 2 superscript 1. So Z of 2 1 will be equal to W1 2 superscript 1 x1 plus W2 2 superscript 1 x2 plus W3 2 superscript 1 x3 plus bias, again optional, and this Z will pass through an activation function again to give us H first layer second node. So after doing all this, you will get 4 outputs because there are 4 nodes. So what are the outputs for the input layer? H11, H12, H13 and H14. Now it is very important to understand the notations because you are going to be needing this again. So inputs have passed through the first layer. We have completed this part. Now let us move on to the hidden layers. Here again, if you will see the inputs, these inputs are nothing but the outputs from the nodes of the input layer. So that is why I said it is important to remember the notations. Anyway, it's become very messy. Let's go on to the next part. Here we have 4 inputs in the first node of the hidden layer. So what will be the weights? First one to the first, so 1 1, and this time the superscript will be 2 because this is for the second layer. Then W21 superscript 2, W31 superscript 2 and W41 superscript 2. I hope you are getting the notations now because I have repeated it a lot of times. So we will have this matrix at the end, W. What will be the dimensions? Number of nodes here, that is 4, into number of nodes here, that is 2. So W 4 cross 2. Now again let us come to the Z part for this F1. Z1 because of the first node and second layer is equal to W211 into, what was it? H11 plus, see, H11, H21, H31, W212 into H21 plus W312 into H31 plus W412 into H41 plus bias, again optional. So you get this Z, that is the summation part is over. Now the function part. So you pass this Z into a function, activation function, whatever function it can be. So there are a lot of activation functions. You will get this output H. This time it will be H1 because the first node, however, second layer. So the 2 outputs that we will be getting will be like this. Okay, now the final part. So we have 2 outputs here. So this is H21, this is H22. You have passing them here. What will be the weights? First node going into the first one, 1, 1. Now the third layer. This is the final output layer. Then here W21 for the third layer, right? So this is happening. Now you will get Z3 superscript 1. We will just have 1 because we have only one node here. So that will be equal to W311 into H21 plus W321 into H22 plus bias. By the way, I did not mention, but all these biases are going to be different for all the nodes. All the weights are going to be unique and all the biases are going to be unique for all the nodes. These are trainable parameters. That means they will keep changing when we are training so that the model finally understands which input is how much important. So that is why the weights and biases are the trainable parameters. The inputs we cannot control. We have to pass the inputs as is, but the weights can be controlled. So these are called the learnable or the trainable parameters. Okay, so back to the thing. You multiplied the weights with the inputs and added the bias, and now you will get the final output, which is equal to function of Z31. This output is also equal to Y dash. So what did we understand from this? This whole process is going forward, right? You have the inputs and you make it go forward, first to the input layer, then hidden layer, then on and on till you reach the output layer to get the final output that is predicted by the model, Y dash. So since in one way you can see it is moving forward, right? So this moving forward is called the forward feed. It's very important to understand this because all the models that we will train and learn actually follow this. So again, let me recap. We have the inputs. They go in one by one. The first part they get summed up, and in the second part they have the activation function and you get the outputs. These outputs act as input for the nodes in the next layer and so on and on. And all these weights are saved in the form of matrices where the first dimension is equal to the number of inputs and the second number of outputs. So this moving forward is known as forward feed. So we moved forward. The next part that we will be learning is how we go backwards and again forward and again backwards until the model learns the weights and biases that are required. That means it learns how to know which input is how much important.